Now what I'm going to do is to give you something called the brief about the vectors. Now what you need to know about vectors, it is something small, that vectors, those are quantities where you'll have to be specific about the direction. Now if they give you vector A to be 0, 3 and vector B to be something like 1, 2, then someone will say find the vector AB, meaning you are moving from A to B. This will be something like OB minus OA. You get the final destination minus the initial destination. Now you'll be having something like 1, 2, then minus 0, 3, then 1 minus 0 will be a 1, then a 2 minus 3 will be a -1. Then this is your vector AB, just something like that. Now always vectors do resemble like that, but this is ordinary vectors. Now if we go for advanced vectors like the one you are covering, we consider vectors of lines, vectors in lines, then vectors in planes, then combination of lines and planes. Now these are huge concepts. Now what you need to know is how to draw a line. Whenever we are drawing a line, like we have a line like this, we could say now in a line we have a gradient, and the gradient is uniform throughout. Now the gradient is when you take that change in y over change in x, that is your gradient. Now you could say the gradient is uniform. Now for vectors, we say this one contains a direction vector, the vector that will be moving along with the line, and we call this one vector B. And we say this vector B will be uniform but will be moving along with the line. Now if we have any point A on a line and a direction vector, then we can say that any position here where I can say that this is point R, this point R will be as a result of getting the initial point A, then plus any value which I don't know, then I have, it has to be a multiple of the direction in which the vector is moving. Now this one yields the vector equation of a line. Now for Cartesian equation, you'll be building this one. You say that if this one is in 2 dimension, it means this one has 2 coordinates. You say this is x, y. Now this one will be equaling to n x naught, then y naught, then plus lambda, then b1, b2, just like this. Then from there you will make lambda the subject in all cases. Now for the first case, you will say that xy, now this is equal to x naught, y naught, then plus the lambda b1, b2. Now when you equate the first part, the first row, you have x will be equaling to x naught plus lambda b1. Then make lambda the subject. Transfer this one the other side, x minus x naught is equaling to lambda b1. Now divided by b1, meaning the lambda will be x minus x naught over a b1. Similarly, the lambda will also be y minus y naught over a b2. Then you could combine both and you could say that x minus x naught over b1 will be the same as y minus y naught over the b2, and this is equal to lambda. Then this one is the Cartesian equation of a line. Even if it is in 3 dimension, which we call the what? The xyz. It is the same scenarios. You'll be equating, making lambda the subject. Then you do something like this. Now what is special about this one is we go to specifically lines. There is other stuff, but it is rarely asked. But what is more asked is how do we go for when we talk about lines in specific, point of intersection of lines, intersection of lines. Then from there we go to angle between lines, angle between lines. Then here before the Cartesian equation of a line and the vector equation, they are these ones we have seen. This one we call it the Cartesian equation, this one. Then the vector equation is the one which we have observed at this point. What we need to get the position A and value of B, just that. Now then, if you understand the point of intersection of line and angle between lines, then that is okay. Now for point of intersection of lines, which we call the point of intersection of lines. Here we equate lines. If you are given line R1 when it is A plus lambda B, then R2 is B plus the mu, then C. Now for these two lines R1 and R2 to intersect, means R1 has to be equaling to R2. Just that if you recall this condition, everything will be okay. Then the angle between lines, when we get the angle between lines, now it means we need to get the angle. Then you have to facilitate it because you don't know it. You say let the angle be any value, you can call it theta. Then after knowing that the angle is theta, then you can go to the dot product and you say that if you have a direction vector b1, that the direction vector b2, the same as the magnitude of the b1 times the magnitude of the b2, then the cos of theta. This one was proved by Mr. Ken. Then it is of no use of me proving it again. Then we get it like that. Now let's see like examples in 2 dimensions. Now if you are given any point A which is a 3, 2 and B which is a 4, 7, then they want you to get the vector equation of a line. Then from the vector will be A will be OA plus any value lambda AB. Now if you begin with the A here, also A should begin here. Over, you see what I'm saying? If you begin with the OA, now this one has to be AB. If you say R is equaling to something like OB, now this one should be plus the lambda BA. The value you write here should be the same value here. There is a reason, because these ones have to be the same. Just they will be differing in the directions. One will be the negative of the other. Now here what we need, that if we are to use this one, already OA we have it is here. Now what we need is AB. Now AB will be equaling to OB minus OA. Then AB will be equaling to another stuff which will be OB which is 4, 7, then minus a 3, 2. Then from there AB will be equaling to a 4 minus 3 which is 1, 7 minus 2 which is 5. Now if you have that, already we have AB as something like 1 and 5. Then we have A which is a 3, 2 which is a 3, 2. Then we can get the vector equation R is equaling to OA which is OA, then plus lambda AB. Then R will be OA which is this one, a 3, 2, then plus lambda AB which is 1, 5. This is the vector equation. You are done with it. If they want Cartesian equation, R will be XY, 2 dimension. Then from there you substitute XY will be equaling to a 3, 2, then plus lambda a 1, 5. Then finally I want you to do the same way I did for the first value. You will find out that X minus 3 over 2 will be the same as the Y minus 2 over 5, and this one will be equaling to the lambda as your Cartesian equation. You try out this to see whether it is that. Now I wanted to see whether it will be beneficial. If it is beneficial, then you like, you comment, and you subscribe, so that I can know that the thing is what is beneficial, so that we can proceed and I make for you other videos about vectors, and we can see vectors in 3 dimensions and rather than 2 dimensions, because 2 dimensions can simplify my work since I'm just writing on papers. Then you comment and I see whether the thing is beneficial. Thank you. We meet again.